Welcome to Tracing Evolution, your gateway to comprehending the intricacies of evolution and the collaborative dynamics of the world. I'm your host, Kennedy Wilson, and each week we explore scientific theories, groundbreaking discoveries, and the individuals who have influenced the future of science. The following episode follows the conversation between an undergraduate journalist, Brian Stockpin, and scientist Charles Darwin, who advanced the understanding of life with the theory of evolution.
It is a privilege to engage in this discussion with you. Traditionally, the Church held the religious belief that all species in their form were created through the design and complexity of God. Can you please explain how you developed a theory that would propose a different idea for the diversity that we see today?
The theory of life proposed the idea that species undergo gradual changes over time, and the changes we were seeing on offspring were dominating traits from pre-existing organisms. This idea was a significant idea, as it contradicted earlier naturalistic beliefs that animals were created by the divine creator. In 1773, James Burnet and Lord Monboddo had begun to suggest that animals transform their characteristics in response to their environment over time, which then led Jean-Baptiste Lamarck to push her proposal that suggested organisms were passing on their traits to the next generation. Upon publishing The Origin of Species, a comprehensive 466-page work, I hypothesized that new species come from pre-existing ones and the organism's ability to adapt to its environment, contradicting the teachings of the Church and setting me aside from the thinkers before me. A significant portion of my research concentrated on phenotypical observations. My 5-week journey to the Galapagos presented me with the opportunity to closely observe the finch population. It became evident to me that finches were exhibiting differences amongst the shape of their beak based on their environment. This observation was critical evidence for the concept that when organisms have advantageous traits in respect to their environment, they were more likely to survive and reproduce various phenotypes. This concept was also a subject of interest for Alfred Russel Wallace. Wallace actually encouraged me to document my findings in a book that I later went on to publish. However, my insight contributed to the understanding that all species are interconnected and evolution progresses through survival of the fittest.
The latest episode of the podcast featured dialogue between Charles Darwin and an undergrad student after the publication of his book. While the principles of Darwin theory are prevalent today, Darwin's perspective may have simplified the intricacies of life. Subsequent research has brought the complexity of nature's change in DNA, genetic rearrangement, and natural selection, which illuminates the mechanisms by which traits are inherited across generations. The tree of life relates all organisms to one common ancestor through modern genetics, which was a concept first illustrated in Darwin Notebook after his voyage. His original classification of organisms based off of phenotypical attributes, convergent evolution, this phenomenon illustrated to the scientific community that it was possible for two genetically distinct organisms to look alike, placing a limitation towards Darwin's theory as the resemblance of animals is the result of the environmental pressures that influence adaptation to select attributes between organisms. Classifying organisms based on phenotypical attributes create the false narrative that they have a close relationship. Genetics being introduced to evolution was a critical factor, for it provided the underlying mechanism for how traits are inherited.
Episode 3 is brought to you by Tracing Evolution.
In this episode, we explore the relationship between James Watson and Francis Crick. The collaborative work of these two scientists would ultimately trace back to the original work of a female scientist from Cambridge University. Please introduce yourself and your contribution to the field of science.
My name is Rosalind Franklin, and I played a crucial role in enhancing scientific comprehension. I had successfully captured DNA's three-dimensional shape using X-ray crystallography. This breakthrough established a connection between the inheritance of genetic traits. Although Darwin's collaborative efforts greatly propelled the theory of evolution, he failed to connect that the genetic information being inherited was systematically organized within the DNA structure. When Darwin proposed that the environmental changes influence the animal's traits, the structural details of DNA was limited, and the mechanisms involved could not be pinpointed outside of phenotypical attributes, and the illustration of the double helix configuration facilitated the efficient replication of genetic information. Identifying the organization of DNA reconstructed the genealogical relationships that link all forms of life.
How did Francis Crick and James Watson contribute towards your discovery?
They did not help me. They are two scientists who took my research and presented it as their own.
Where do you perceive science to be in the future in relation to our current position?
I see women becoming pioneers in the scientific field and science advancing. While my own discoveries may not have been documented within the scientific community in the traditional sense, that does not define my identity. I take pride in having identified a crucial element of evolutionary theory, and I am glad to have discovered a key aspect.
Science is an ongoing and dynamic process that requires scientists to work meticulously to record all developments, to refine existing theories, or develop their own. In the upcoming episode, we will examine genetic drift and its relationship to speciation. The DNA replication process produces two identical daughter DNA molecules from the parent DNA. DNA contains specific segments that provide the instructions necessary for the synthesis of functional proteins in organisms, which are inherited from parents to their offspring. DNA replication always leaves room for mutations. Factors that increase the possibility of a new lineage come from genetic variation within a population. Reproduction isolation and geographical barriers enable species to remain distinct and facilitate the exchange of similar genetic information. The introduction of new genetic information can come from a mutation or a change in geographic patterns. However, mutations themselves don't directly result in the emergence of a new species. Genetic transfers take place through multiple mechanisms, which demonstrate the numerous ways in which organisms can exchange genetic material. Vertical gene transfer refers to the transmission of genetic information from parent to offspring, while evolution transpires at the population level rather than at the individual level, which explains the gradual changes observed in a population prior to more significant impacts over time. Environmental factors shape traits alongside the selective pressures imposed by the environment. Evolution isn't pursuing a specific objective, nor does it seek to create an ideal organism. Traits may be lost if they have traits that become unnecessary for survival in the given environment, while new traits emerge. With environments constantly changing, the concept of a perfect organism that can survive and reproduce under all conditions is unattainable. Changes in allele frequency arise because of mutations, genetic transfers, and the influence of the environment on natural selection. Although organisms may appear to be the perfect organism, it is because they possess advantageous traits that align with their specific environment. The analysis of the current condition of polar bears reveals the impact of environmental changes affecting allele presence in populations. Polar bears are now at risk of extinction, and the rise in temperatures has made their dense fur less advantageous and altered traditional hunting practices. The elimination of geographical barriers has allowed polar bears to explore new territory, which has led to interbreeding with other bear species. This has resulted in the emergence of growler bears, and the disruption of gene flow illustrates the speciation process. This phenomenon illustrates how environmental factors can facilitate the development of a new species through the introduction of new alleles into the gene pool. This example also exemplifies the gradual evolution of species through various mechanisms of genetic transmission, including the removal of geographical isolation that affects reproduction. Episode 5: Survival of the Fittest. Various species of small animals exist in harmony with their larger counterparts. This episode dives into the concept of survival of the fittest and what it truly entails. Evolution is dependent on reproduction and the transfer of advantageous traits being passed on to future generations. As a result, only organisms that contribute to their lineage are deemed significant. The principle of survival of the fittest proposes that organisms who have genetically inherited traits that enable them to adapt to their environment are more likely to survive and reproduce, thereby passing those beneficial genes to their offspring. While the environment dictates which traits are advantageous, evolution does not aim to create the most optimal organism. In fact, it does not pursue any particular objective, but instead favors traits that are most compatible with the existing conditions. Not all traits are essential for survival. Sexual selection primarily influences the development of characteristics that enhance mating success, and as a result allows animals to pass on their genes and unique attributes. Animals evolve traits that promote reproduction, as these traits enhance the likelihood of attracting mates and producing offspring, which is a crucial element of evolution. This understanding highlights that evolution arises from change in inherited characteristics and traits. The focus is not merely on the longevity of animals, but their capacity to reproduce and transmit advantageous traits to future generations. In the case of frogs, females are attracted to males with stronger voice boxes. Males may also possess protective features for combat or unique patterns that women are attracted to. Traits that enhance reproductive success will become more prevalent due to their effectiveness in mating. I have utilized my podcast as a platform to investigate the concept of what evolution entails. In the first episode, I presented Charles Darwin to discuss the origins of the theory of evolution and the idea he proposed, which links all living organisms to a shared ancestor. This was intended to clarify the misconception of convergence evolution and transition into the second episode, featured an interview with Rosalind Franklin. This discussion emphasized the connection between genetics and scientific progress that elucidates the true reason behind the diversity observed among organisms, suggesting that new organisms are introduced from a mutation or from the introduction of a new allele. The subsequent episodes delve into topics including genetic drift, speciation, sexual selection, and evolutionary advantages to provide a comprehensive understanding of evolutionary genomics and its connection to genetics, ecology, and physiology across generations. I hope you enjoyed this series as much as I have. And as always, this is Tracing Evolution with Kennedy Wilson.